Hi, I'm Allie.
And I'm Andrew.
And I'm Ken.
And we're from Cal Poly in San Luis Obispo, and we'll be describing the X-ray spectroscopy lab. The general purpose of this lab is to analyze the elemental composition of metallic samples and to verify Moseley's law. Kevin?
Thank you. So behind this shielding, which is here to protect us, is our americium source. Here, can you move this out of the way so you can see this right now? So here's the americium source. It emits gamma rays. The gamma rays come up and strike our sample, which in this case is iron. Once the electron hits it, then an inner shell electron is ejected from the iron atom, and then a outer shell electron falls in, emitting an X-ray. The X-ray comes down and strikes our detector. The detector will emit a voltage pulse, which is proportional to the energy of the X-ray that hit it. The pulse then comes in and hits and goes through our amplifier and then to the computer. The computer then places a little hit at a channel which corresponds to the height of the pulse. However, it needs to be calibrated so we know what energy it corresponds to.
Like Kevin said, we need to calibrate our system so that we are able to determine the energy levels of each of the channels for unknown sources. Now what we do is we take a known source such as iron or nickel or zinc, and we take a spectroscopy of them in order to find out what channel numbers get lots of hits. Now then what we do is we look up in a table the energy levels of the common transitions and the relative intensities, because there are usually multiple transitions corresponding to the kappa alpha and the kappa beta transitions. Now we do this for multiple different samples, and we get a graph of the channel number versus the energy levels of the transitions, and then we can do a curve fit and get a nice calibration equation so that we can determine the energy levels of any of the channels, which allows us to find the energy levels of a transition of an unknown source.
So what we can do is that if we take any random object with some metal in it, it will have specific X-ray energies that's unique to what elements it contains, because each element has its own specific energy levels. So in this case, for example, we have a gold thread, which I bought off the Home Shopping Network, and is supposedly painted with real gold to get its color. Let's find out. So I've just placed the thread above the source, and then we tell our computer to start counting. And then after some time, we see what peaks it corresponds to, what peaks show up. Now in the gold thread's case, it turns out that it had 2 peaks which corresponded exactly to that of copper. I wasted a lot of money. However, we can also use this X-ray spectroscopy to confirm certain laws such as Moseley's.
Ooh. Alright, Henry Moseley showed that the energy transition for specific samples directly related to the atomic number of that sample rather. So we were able to test multiple samples and determine a relationship between the square root of the energy of the transition to the atomic number. We were able to then use this relation to determine the composition of our samples. And so as you can see, the X-ray spectroscopy lab allows us to verify Moseley's law as well as to determine the elemental composition of our samples. Thanks!